A projectile is an object upon which the only force acting is gravity. Examples of projectiles: an object dropped from rest, thrown vertically upwards or thrown upward at an angle to the horizontal, provided that the influence of air resistance is negligible. A projectile is any object that once projected or dropped continues in motion by its own inertia and is influenced only by the downward force of gravity. The analysis of motion associated with a projectile is known as projectile motion. The components Vx and Vy can be found if the angle theta is known. Vx is equals to V times cosine theta, and Vy is equals to V times sine theta. It must be noted that in projectile motion, the horizontal motion and vertical motion are independent of each other. That is, neither motion affects the other. From the xt graph obtained, we have analyzed that the gradient of best fit line is linear to the origin of the xt graph. Hence, the velocity of the object remains constant throughout the projectile motion. The formula for x is 0.401 t plus 0.025. The horizontal velocity of the tennis ball is 0.401 meter per second, and the horizontal acceleration is 0 meter per second since object is moving at constant velocity in the horizontal direction. From the VT graph obtained, we have analyzed that the gradient of best fit line is negative such that the VT graph is downward sloping. This indicates that the tennis ball undergoes uniform deceleration till it reaches its maximum height, where velocity is 0, after which the tennis ball experiences uniform acceleration in the opposite direction. The formula for V is negative 0.512 meter per second times t plus 0.679 meter per second. The initial velocity of the tennis ball is 0.679 meter per second, and the vertical acceleration of the tennis ball is negative 0.512 meter per second squared. From the YT graph obtained, we have analyzed that the best fit curve tells us that the ball is slowing down as it reaches its maximum height and starts to speed up and accelerate when it falls. The formula for y is negative 0.256 meter per second squared times t squared plus 0.667 meter per second times t plus 0.003 meters. The initial velocity of the ball is 0.667 meter per second. The vertical acceleration is negative 0.512 meter per second squared, and the direction of vertical acceleration is downwards. We have also obtained that direction of vertical acceleration is downwards, and the values obtained from the YT graph are similar to that of the VT graph. The true value of vertical acceleration is negative 9.81 meter per second downwards. The percentage error of vertical acceleration is 17%. An example of a random error is parallax error, such that position of the ball may not be positioned exactly horizontal to that of the bin. An example of systematic error is the ruler for tape measurement may not be placed vertically in the video. Amber questions would be: is the horizontal component of velocity constant throughout the projectile motion displayed by the tennis ball in the video? Did the tennis ball experience any form of acceleration throughout its parabolic motion? And how does air resistance affect the projectile motion in terms of the horizontal and vertical component of velocity? Here are some preamble questions and the answers to them. Question 1. Is the horizontal component of velocity constant throughout the projectile motion displayed by the tennis ball in the video? The answer is, the horizontal component of velocity is constant throughout the projectile motion. Question 2. Did the tennis ball experience any form of acceleration throughout its parabolic motion? The answer is, the tennis ball undergoes constant acceleration or deceleration throughout its motion. Question 3. How does air resistance affect the projectile motion in terms of the horizontal and vertical component of velocity? The answer is, the vertical component of the velocity will decrease more when rising and increase less when falling. The horizontal component of velocity will decrease continuously and eventually reach 0.